Hi everyone, it's a very good afternoon to all of you guys. So today in our maths clinic, we're going to cover two chapter. Well, I mean, not really two chapter, two important things. One is mensuration and another one we'll cover is trigonometry. Okay, so the maths clinic has been organized in a flow that will cover a little bit of formula. And after formula, we'll cover a few example of questions. I won't go through all the questions, maybe selected questions, and some you guys can try on, and we'll enter trigonometry and we'll do some past year questions. That's the plan for today. Okay. I think without further ado, we should actually start our maths clinic. Okay. Beta guys, let me just adjust first the screen. Okay. So in measuration, what are the stuff that you need to know? As usual, not to say as usual. Okay, the whole point is that you guys need to know a certain specific formula. So I'm going to highlight for you. Okay. Area of rectangle, by natural itself, you should know already what is area of rectangle, which is length times width. Area of triangle, if you see here, their representation is slightly different. Okay, they put as b times h over 2, which is same as 1 over 2 times base times height. And whereas for trapezium, it's a summation of the sum of the parallel side. Okay, so you can see here, probably I try to zoom a little bit for you guys. Wait on. Okay, so as you can see, there are two parallel sides here, which is the A and the B component. So you need to sum the two parallel side, multiply with the height, and multiply the height, and then multiply 1 over 2. So you can see here in a small writing, they make that A and B are parallel to each other. So this is something that you want to take note. And moving forward, we have area of circle, pi r square. Area of parallelogram is base times height. So area of parallelogram is very similar with our area of rectangle. Because why? They are the concept is like this. Imagine you place your finger here. Can you see my orange color circle? Okay, I place my tip of my finger. I hold at this edge here and I'm stretched. So when I pull and stretch, this rectangle is the one that become a parallelogram instead. So that's why the formula is still the same. But however, you must take note, be base times height. The height must be perpendicular height. At certain occasion, the question will give you the slanted height, also known as L. So when they give you L, what you should do instead, you should actually use Pythagoras to find the perpendicular height. You can't use the length as a base to calculate the area of parallelogram. Unlike our rectangle, of course, because the width itself is the perpendicular height. But for our parallelogram, it's not. So it's a bit different. And the next part we will cover is the area of sector. Okay, this thing probably I'll just change my highlighter color. I noticed along the way students have difficulty to memorize the formula. The concept is very simple. If you notice, area of sector formula and area of circle formula is exactly the same. They are pi r square. The only exception they have here is the constant in front. Can you see? I highlight in a blue color. So why they put a constant? Along the way, I have taught my students before that actually this sector is made up from an entire circle. Okay, we use a full circle, we just extract part of that. So to exactly narrow down what is the part we're looking at, that is why this ratio comes up, theta over 360. Okay, so please take note on that. They are actually the same, because along the way when I asked to them what is the formula to calculate area of a sector, what they do is that they will get confused that, so what's the formula, and then they tend to get mixed up with theta over 360 times 2 pi or some other relevant irrelevant formulas they used to say. So my trick is, area of a sector is actually made up from a whole circle. So from the whole circle, we only extracting one part of the sector. That is why we are taking that sector's angle divided by the total circle, which is 360, then multiply pi r square. Okay, I think that's pretty much about the area formula. Without further ado, I think we should actually start the next one. All right, I think I have one more formula I wanted to cover, but wait, that formula is not here for some reason. Wait, guys. Oh yeah, it's here actually, area of length. Okay, good. Now the next one we want to counter is that the perimeter. What is perimeter actually? Okay, perimeter is actually the summation of all the sides outside. Okay, you see the concept is like this. Area means you want to know how big the area is. It's, for example, I'm building this area. Wait, I selected black color, but another color came. So imagine this is my entire area, and I want to know how big or how circle is the area so that I can fit object inside here. So this is what we call as area. Likewise, students used to get confused the difference between area and circumference. They can't differentiate. So what is circumference actually? Circumference. Okay, what is circumference actually? The concept is simple. Imagine you take a piece of a piece or whatever lah, a string measure 5 meter. So this exact very string, I'm going to bend it to become a circle. If I form this circle using this string, that means when I measure this entire circle, the length should be 5 meter as well. Agree with me, right? So that is the concept of circumference. Circumference is actually how long is the entire area, whereas area, we don't know how many objects we can fit inside. Okay, so now with that, perimeter is the measure of the edge. Okay, whatever the definition is, the point is, if I want to find how long is my circle, okay, take note. If I want to find how long is my circle, all I got to do is just use this formula here, 2 pi r. Okay, please take note of the difference. Circumference is 2 pi r, whereas area is pi r square. Okay, this is another part that I would like to take off this slide. Student will get confused the formula between area and also circumference. They tend to get mixed up with these two formula. So I'm going to share you the tricks how I've been doing along this way. For area, the formula is pi r square, whereas for circumference is 2 pi r. Of course, when I say like this, it's easy for you to understand. But how do you actually avoid the mistake of mixing up these two formula? The key is, if you notice, area, our SI unit. What is our SI unit for area? Our SI unit for area is often to be cm square, meter square, or whatever, but it's always a square. Whereas for circumference, it's always cm or meter, is without any power on top. So with that in mind, you can know that for area, I must have a square here. The radius must be square. So when the radius square only, I will get my cm square. Whereas for circumference, we already know there shouldn't be any square, so it must not have a square. So in that way, you can avoid that problem of forgetting the formula. Okay. Now, next one, let's look into our arc length. So in our arc length is basically similar concept with our area of a sector. As I mentioned earlier, we are extracting. We want to know. Let's say I have a circle over here. Okay, from this big circle, I only want to know the portion of that. Okay, wait, let me just select another color. Okay, so I just want to know part of this length. I want to know that small pieces length. What is the value? Same concept. You just take that angle associated with that small minor arc, theta divided by the entire 360 times 2 pi r. So if you notice, they have a huge similarities here. These two formula. Can you see? You see, yeah, they have a huge similarity between both. It's still the same 2 pi r, just the difference that instead of taking an entire circle, we are only looking at the level of one small arc. I used to call a pizza. Okay, that's pretty much about the formula. Now we're going to cover about 3D shape. So all this long we have been talking about 2D shape. Now we'll cover about 3D shape. In 3D shape, we have got several formula. First one is to calculate the surface area for cuboid. The word cuboid itself already tell you a huge meaning. Cuboid means it's just a box, a rectangle basically being extruded. And if you notice, it's just 2 multiplied with, if you notice the formula they put in terms of box. So what are they trying to tell? This dimension probably is length, width, and height. So they want you to actually find this red color surface area, which is length times height. So I'm going to put here length times height, and then 2 times the top part, which is length times width, and then 2 times on the left hand side, which is width times with height. So that's how we actually find the surface area of a cuboid. Right? So they have double because each side they have double, front and back, left and right, top and bottom. Okay. Now the next one, surface area of a cylinder. So a surface area of a cylinder, how do? We need to understand the formula first. We have 2 components involved. One is the curved part. Another one is basically the top and bottom circle. All right. So if you notice here, let me just illustrate to you guys. This 2 pi r square is actually the top and bottom. Sorry if my writing is too small. Okay, but I think it's too small. Pity you guys, you won't understand what I'm writing. Let me just increase the size. Okay, so this formula is actually talking about the top and bottom. Okay, so you can see the top part here, our cylinder is a circle and the bottom is a circle. Therefore, the surface area comprises 2 parts. One is the top and the bottom because of circle. Therefore, it's 2 pi r square. Whereas for this formula here is actually this entire curvature. You know, like when you buy a bottle, or maybe you buy a Pepsi can, around there they have a labeling like with some sticker or something. So this 2 pi RH is actually illustrating that thing here. Okay, I afraid that I will draw the wrong thing, but I hope you guys can understand what I'm trying to illustrate over here. Okay, so it's actually this curvature. Can you see this curve part? Okay, so that's the 2 pi r h actually from. So surface area formula, usually in IG they won't give, so you have to memorize. Usually in IG they'll give you the very standard common one. I will take in a while. Don't worry, I'll take in a while. Next one we have is surface area of a cone. So for surface area of a cone, same thing if you notice. Pi r square is actually the circular base. You can see, right? It's the circular base. I'm going to write here. The circular base. Sorry for my spelling. The moment I start to increase the thickness, it become quite ugly. Okay, so circular base, you can see. So this formula is actually the circular base, whereas the other formula is basically the top part, the cone part. So the top part I cannot draw for you guys, but I hope you can relate. This is actually your cone. Okay, this is the cone of the entire thing lah. Okay, now last one is surface area of a sphere. Surface area of a sphere, because it's just a ball, it's just 4 pi r square. Student tends to mix up this formula as 4 pi r cube, because the volume formula is 4 over 3 pi r cube, you see. So they tend to get mixed up between these two formula. My advice for you is you are finding for surface area. Surface area formula or SI unit is always cm square, meter square, or whatever the SI unit is, but it's always power 2. Therefore, with that, you can eliminate the error next time when you write an examination. It's just 4 pi r square. That's all the formula. All right. Okay, and then we have another type of formula. Not to say another type of formula, a formula for another set of shapes. One is volume of a cuboid. So volume of a cuboid, as they label here, length times width and height. Basically, the volume of a cuboid is quite easy because all three sides should be the same. I mean, not to say cube should be the same. Cuboid is not the same, but it's not that big deal. It's same as a cube. Next one, we have a volume of prism. Okay, this volume of a prism, I want to write a separate formula here because I've written for you guys many times in the class as well when we are doing the. I'm sorry, I need to be general, right? Okay, I believe Miss Marisa and me also already cover. I'm going to write here. The volume of a prism, we have a very general formula, which is cross-section area times length, width, or height, depending what is provided to you during the examination. Okay, so remember the formula. Volume of any type of prism is cross-section area times length, width, and height. Now, the next thing about cross-section area is the same. Okay, the same area projected. Wait, guys. Same area projected through, you don't need to write this definition, okay? I'm just writing for you to see. Same area projected through a specific, okay, a specific length, width, or height, okay? So like for our example here, if you can see, this is a triangular shape being projected or extrude for a certain length, which is called L. So maybe I might have another situation where I have this weird shape here and I extrude this shape to form a 3D shape. Also possible. So if you notice, the cross-section area for this drawing that I just draw for you guys will be this one. Because you notice the same area only I extend. So for this, we'll have height instead. That's why I put here length, width, or height. It depending what is provided to you in the exam. Okay, that's volume of a prism. And you can see the same concept only they used to apply throughout other shape as well. To find volume of a cylinder, like I mentioned just now, you see the drill here. My similar cross-section area is this entire circle up there. Okay, so what I do is actually this circle is the one that I extrude for a specific value called the L. So that's why it's pi r square multiplied by L. Okay, now next one, volume of a pyramid. Okay, for volume of a pyramid is a bit different because why? A pyramid is not being extruded to a certain specific same amount of what we call a cross-section area. So pyramid is a bit challenging. They have a formula and you need to remember the formula. It's 1 over 3 times length. The length must be perpendicular length. Please take note of this thing. Okay, your length has to be the perpendicular. Maybe I'll just write a note here. Okay, it must be the perpendicular, not the slanted one. At usual occasion, your IG like to confuse you guys. They'll give you the what we call that, the slanted height. Slanted height means they'll put an L there, but this one is a H. I think there's a error. Oh yeah. My bad actually. Yeah, they actually put height. You can see, so the height, the height should be the perpendicular height. So I think I should emphasize on that a little bit. right? You can see here. So the height should be the perpendicular height. And the last one you have is volume of a cone. So volume of a cone is 1/3 pi r square h. Okay, guys. And the last one will be the volume of a sphere, 4/3 pi r cube. So as you can see, I can keep talk on and on and on and on, no point. We need to put into some application, right? So I'm going to show you, I'll just choose few shapes to show you how the formula is being implemented in this question. Let me just choose a good color. Okay, now for question 1a. So in question 1a, what do I have actually? Okay, 1a, they want you to find a cone with a radius and a height. Okay, so they want you to find a volume. Read the question first. They clearly mentioned they want you to find a volume. So I guess we'll find the volume first. So to find the volume will be the formula you should know. Cone formula is basically, if I'm not mistaken, oh God, just give me a moment. I need my calculator, guys. So just wait. Let me just pause first. All right. So the formula for a cone. Let's go find the formula for cone. I think I saw somewhere here. Yeah, it's that. Okay. Now let me screenshot the formula. Formula of a cone here. Okay. So you can see. Good. Yeah. It's a bit hanging because why? There you go, the formula for cone. So I'll put it here side here so you can see. Now for the formula for cone is basically 1/3 pi r square h. Therefore, I don't think we need to write the formula. We can directly substitute and get the answer. So it's 1/3 multiply with pi multiply with radius square. Okay. So we're going to multiply radius square. Our radius is 4 square times with our height. Since they mentioned height, then it shouldn't be any problem. Okay, because some of you might be asking me, sir, is this a slanted height or something? Yeah, it's definitely a slanted height. Okay, it can't be other height. And we will have 83.775, but IG standard is 3 significant figures, so it should be 83.8 cm cube. Okay, now 1a done. Let's look at 1b. So in 1b, they want you to find a hemisphere, volume of a hemisphere. So remember, volume of a sphere was what? Okay, wait, volume of a sphere was 4/3. Wait, I'll screenshot for you guys. So volume of a sphere was, I put it over here. That was the volume of a sphere. And you notice this is for a full sphere. Right now, we are looking at a hemisphere. So don't forget to divide by 2 later on. I'll have pi times my radius. You see, they give you the diameter. So you need to find the radius. It's quite easy. Just divide by 2, which is 5. So I'm going to substitute here 5 cube, everything divided by 2. And make sure when you press in your calculator, use the correct substitution. Otherwise, you might pay the price for that. And you'll get 261.7. So 261.7, I guess 262 cm cube should be more than enough. So I don't want to do for sphere because sphere is an easy one. Cone we already done up there, sphere we already done up there, cone also. So it's repeating all over again. You guys can try out based on the similar method since the formula already provided for you there. Okay. Answer, I guess, if you need answer, just email to me or Miss Mirisa. We definitely will help you guys out. Now for the next one, if you notice, they want you to find the total surface area of the following solids. Probably I'll just do some cone and sphere because the rest is being repeated all over again. So we'll just look at a cone. Now for question 2a, we want to find a cone. Let's go and find the formula. I think the formula was given up here. Surface area for cone. There you can see pi r square times pi rl. Probably I'll just erase this scribbling of mine so I can screenshot the what we call that, the formula. So this is the surface area for cone. Wait, okay, so I'll put it here. Surface area for cone. So that's the formula there, and we're going to use this formula now. Okay. So to use the formula, let's check. We have radius. Good. Okay, we can do. So I'm going to write it SA. SA for me stands for surface area. You do what else is okay, but it's advisable to do a proper labeling. So when you want to check your working, upon finishing your paper, it's much more easier. You can relate what are you looking at. And radius is again 7. And my slant height, remember I told you the length must be slant height for surface area, but for volume is the perpendicular height. Okay, so you can press in calculator 7 square times pi plus pi times 7 times 21, and I'm going to get this 615.7, which I can make it 616 cm square. Right, that's for 2a. I don't want to do again the same thing again, but however, I think we should consider question B. Because question B, they give you the height. Let me just draw it for you guys. So if you notice now for question 2B, this is question 2B. Sorry for my ugly drawing. This is question 2b. What they gave you is the height. When they say height is the perpendicular height, take note. Okay, so they give you the height is 0.4, but our surface area formula require us to obtain the L, which is the slanted height. It's not a big deal. You can actually use Pythagoras. You can see I got 0.3 down there. I'll draw as a triangle, okay, so that you can see. Now, guys, okay, we can see I draw this triangle out here. Okay, so this is 0.4 the height, and this is 0.3. Using Pythagoras, I can find the L easily. So I'm going to write L equals to 0.4 square plus 0.3 square. And I'm going to square root this thing, and I should get my answer. Okay, 0.4 square plus 0.3 square. Then you set the answer. You're going to get your slanted height as 0.5 meter. Done. So now we got a slanted height. We can actually substitute in our formula. So 2b formula will be surface area equals to pi times our radius was 0.3 square plus pi. Our radius is again 0.3, but no square instead, and our L is 0.5. So these are the common mistake that student would do. That's why I share with you guys. Remember, surface area we always utilize the slanted height, whereas for the volume we always use the perpendicular height. I mean, there's a long explanation about that. So you'll get 0.753. I will leave it to 0.754. Okay, so 0.754 meter square. That's for 2b. So the rest is cone. So I don't want to explore a lot about that. Maybe we can just try another variation, which is sphere. Surface area of a sphere is given up here. I'm gonna put it down there. Okay, let's paste it here. It's easier for us to see and do. Sphere, where I use sphere. Okay, here's sphere. So I'm going to do question 2D now. So for question 2D will be, because the formula is such, I'm going to write the surface area is 4 pi. Our radius is 2 square. So you can leave your answer in pi if you want. If I was you, I would leave it in pi. It's much easier for me. Okay, 16 pi meter square, or you want to press the pi also can. So how do you decide whether you leave in pi or not? Read the question. At certain occasion, they'll tell your answer must be in 3 significant figure. Certain occasion, they'll say you must leave as a pi. So just follow whatever the question say. Next one, they say a triangular pyramid, identical faces of side 3 cm. Probably I'll do this question now. Okay, so they say a triangular pyramid, identical faces of sides 3 cm. Triangular pyramid. What is triangular pyramid? A triangular pyramid, triangular pyramid, triangular pyramid. Oh, a triangular pyramid. That means they are trying to tell you that a pyramid definitely must be a square base. Okay, it can't be some other base. So what they're trying to tell you, this is the triangle's dimension. Wait, guys, I can't draw perfectly. Hopefully, it converted. So this triangle, it should be a bit slanted. Then only you can see. Because I want to form a 3D shape, right? Okay, like that, right? Good. So then I'm going to project it a little bit up. Wait, I'm going to project it up here, here, and then here. So what they're trying to tell you, this is 3, this is 3, and then the top here, identical faces of sides 3 cm. So 3, 3, and this slanted also is 3 cm eventually. That's what they're trying to say. So how can you find this this surface area? Basically, I'll show you step by step. First, you need to find the base surface area. So I'm going to write here question 2F. Sorry, it's question 2G. Question 2G, I want to find the base. So probably I'll just label this as B. BA stands for the base. So I write here surface area of BA is equals to 3 times 3, which is 9. Now I want to find for the triangular. You know the triangle shape up there, we got total 4. So that one I will label as T. Okay, so I want to find S for T. Probably surface area of triangle will be 1/2 times our height. We don't have our height, but we can find. My drawing is quite ugly. I'm so sorry. I'll try to redraw it nicely. So imagine I take out one of the sides. Okay, imagine I take out one of the sides. So right now I have the sides here. Okay, so this is 3 meter in length. Okay, and then I have my slanted height, which is also 3 meter. How I know 3 meter? Because they already mentioned to you itself a triangular pyramid with identical faces of side 3 cm. That's how I know each side is 3 cm. So I need the vertical height only, then I can use the formula 1/2 times height times base. And this is the height we're looking at. It's quite obvious. this one is 1.5, you can use Pythagoras. I'm going to label this as H for some reason. So H will be equal to 3 meter minus 1.5 meter, and don't forget your square root. Okay, so 3 square minus 1.5 bit. 3 square minus 1.5 square, I'm going to get it 6.75, and when you square root, you're going to get 2.6 lah. Okay, so 6.75, and when I square root, I'm going to get 2.60 eventually. We already got our height is 2.60. I can substitute inside here. 1 over 2 times 2.60 times the base of the triangle, which is 3. However, because it's a pyramid and the base is a 4-sided, so you need to times 4. Okay, and you can press this in calculator. You should get the answer at ease. 2 times 3 times 2.60. I'll get 15.6. Okay, some of you will be questioning why is he saying 2? Because why this 2 and this 4 I simplify become 2. And once I got that, if I want to find the total, I write it T as A equals to 9 plus 15.60, which will give me 9 plus 15.60 will give me 24.6. Okay, 24.6 cm squared. All right, so for the base, I think the rest you can do yourself. It's similar concept, so yeah, we can cover more question if you want. All right, now for the next question, let's look at the next question. They say calculate the perimeter and area of each of this compound shape. They want you to find the what we call that, the perimeter and the area. Probably I'll do one for you, and the other one you can try by yourself. Okay, so if I want to find the perimeter of this, it's quite easy. First I need to identify my what we call that, my length. So this is 4 cm. This one will be, because it's not really that important. The whole concept we want to know is that from here to here is 16 cm. That's all we want to know. Because some students will be cracking your head how to find this length here. There's an overlapping of 8 and 8. You don't care. The whole length is 16. That's all we need. Okay. So with that in mind, I can actually find my perimeter easily. I'm going to write here perimeter easily, which will be 8 plus 4. Okay. Plus 8. No. Done. 8 plus 4, I'll tick SI plus 8 plus 4, and then this whole length is going to be another 16 there. All right, so I assume I already done this too, and then we haven't done this one here, so we need to do this here. That will be basically 2 cm. Give me a moment here. Okay, so we 8 plus 4 plus 16, which is the total length. Then you notice the small tiny pieces there, which is just a 2 here. So I'm going to go plus 2. Then here I have another 2 there. So I'll just go and plus another 2 there. And how about this length here? Okay, so this length we're going to start. So it doesn't matter. The whole point is, if this is 8, this is definitely must be 8 lah. Okay, because the whole length here is going to be 8 actually. Okay, it's going to be 8 actually. Oh, no. Actually, it won't be 16. Because why? There's a little bit of overlapping there. Okay, tell you what, I think for this question we need to rework again. Wait, let me rework again. Just give me a moment. Okay, so let's rework. If you notice, I bisect here, and what I saw is that this is actually the center. So if this is center, this half should be 4 meter, this half should be 4 meter, and here we have another 4 meter. Okay, so that's how I noticed lah. Okay, this is 4 meter. So yeah, now we can go and find the perimeter easily. Basically 8. Okay, so I'm going to write here 8. So 8 plus this thing here, which is 4. So plus 4, then plus this thing here, plus 4. Then this thing is 2, plus 2, plus 8, which is here, plus 2 again, which is here, plus 4, which is here, then plus 4 again, which is here. So I already add everything. All you got to do is just press your calculator. 8 plus 4 plus 4 plus 2 plus 8 plus 2 plus 4 plus 4. And I'll have a 36 here. So that is my perimeter, 36. Okay. Now to find the area, is much more easier, I believe. Let me just clear all this drawing first. To find the area, what we can do, we go and find part by part first. Okay. Up to you and do together so can. If for me, I'll do part by part. So this is part A, this is part B. So to find the perimeter for the area for part A will be 8 times 4, which is 32. And then to find the area for part B, sorry guys, area for part B will be 2 times 8, which is 16. So to find the total area, I write here TA's total area will be 32 plus 16, which eventually give me 48 cm square. Finish. All right. So that's how you do it. You can try question B for yourself. It's quite easy and same. You try. If you cannot, of course, you can find us lah. We'll be very glad to explain to you guys. All right. Now, next question we are looking at is for the each prism. Calculate the area of the cross section. So now they want you to find the area of cross section. How can we actually find the area of the cross section? Basically, there's two things they want you to do. One is the cross section area and the volume itself. Okay, so let's just focus first on the cross section area, then we cover the volume. So for the cross section area, I'm gonna split into a few parts. Okay, I'll split into a few parts. So this is A, this is B, this is C. So I'm gonna find cross section area for A. That will be, if this length is 4, the height should be 3. You can see whatever behind here, it's there. So for the A will be 3 times 4, which is 12. Now, cross section area for B. So for B, if you notice, this is 3, this is 3, this is 6. That means the whole height should be 12 and the width is 7. So 12 times 7, which is 84. Okay, so I didn't write the unit. Just make it as a habit to write the unit. Cm square, cm square. Now for the last cross section area, which is C, that small one, I guess should be the same. It's 3 and 4 again. So it's the same thing. It's just being duplicated again. So 12 cm square. Therefore, my total cross section area is going to be 12 plus 84 plus 12. So that's going to give me 12 plus 12, 12 plus 84. It'll give me 108 cm square. Okay, so right now I already got my cross section area, Roman 1. And I'm going to answer Roman 2. Okay, so for Roman 2, they want you to find the volume. Remember, I told you the formula. To find a volume for any type of prism, it's cross section area multiplied by the length, width, or height. Right now in our question, what was provided to us is our cross section area we really obtained 108. However, our length and width is given here 4. Can you see my mouse cursor? Okay, this thing is 4 there. So I'm just I got a times 4 and I should get my answer in power 3. So I'll have 432 cm cube. That's my answer. Okay, so you can try the same thing for question B. I don't think it's hard. You can try, of course. Okay, if cannot, you guys let me know lah. Right, so pretty much that's about measuration. Later we'll cover a bit of past year question and you'll see how measuration is actually being implemented in past year questions. Now we're going to focus on trigonometry. Okay, let's cover the importance formula in trigonometry. The most important one you need to know is the trigonometry ratio, or also commonly known as Sohcahtoa or Sohcahtoa, doesn't matter. I want to what we call that, explore this a little bit of depth. Usually whichever angle you're looking at, like you see this is called theta, this angle here is theta. Imagine this angle here is your eyeball. So you place your eyeball here. When your eyeball looks straight, this gotta be your opposite. Imagine you're standing in front of your friend, you're looking straight at your friend. So you look straight at your friend, that's your opposite. So that is why whatever you look straight is opposite and your adjacent is basically your neighbor. Some students tell me, so why not the adjacent is here instead? Why it has to be down there? Usually a neighbor, I call it a neighbor is connected by the 90-degree angle. Okay, so if you notice here, there's no 90-degree involvement. So that's why your adjacent cannot be, this green color cannot be your adjacent. Okay, the only way your adjacent can be is the one that is being connected by a 90-degree. So with that in mind, just remember this eyeball opposite and the one that connected by the 90 degree is adjacent, and the corresponding should be your hypotenuse. So there are a few formulas, not to say formula, the trigonometry ratio that you should know. The first, the name goes by Sohcahtoa or Sohcahtoa, whichever you prefer. The whole idea is that for So is basically, you can see it's opposite and hypotenuse. Some students will think, sir, is it sine opposite times hypotenuse? No, friend. It's actually sine is opposite divided by hypotenuse. Cos is adjacent divided by hypotenuse. Tangent is opposite divided by adjacent. Right? So that's how we actually work with this formula. You can see here, they're written for you clearly over there. It's always divided by. Don't get confused. And if in any occasion I need to find the angle here, what we will do, we'll shift the sign over. So when you shift the sign over, it'll become inverse sine. Okay, please don't get confused. Inverse sine is not necessary like this. Okay, this is not the same. They are totally different thing. Later on, we will definitely explore this kind of problem. As we explore, you will learn. Okay, we learn from mistakes. So be positive and don't be upset about it. Guys, I think my Microsoft whiteboard is full of stuff, so it's starting to freeze already. Okay, never mind, doesn't matter. The next one in trigonometry you should know is the Pythagoras theorem. So in Pythagoras theorem, he have said that a square plus b square c square. So this is the part where student will get lost. I'm going to make it clear here. This a and b are the two length or the two sides that are connected by the 90 degree. Remember that. Okay, this a and b must be the connector between 90 degrees. So c is always your hypotenuse. Please don't ever mix up with this. Okay, I just write hypo. So remember your c is always your hypo. The A and B are the ones that are connected by the 90 degree. Okay, so you can see there are a few examples there. I don't think I want to talk about the example. What I want to talk is that, remember, A and B are connected by the 90 degree. Later when we do some example, you will see better. And then we have another set of formula, Sine Rule. Okay, so you might be wondering, sir, why you got Sohcahtoa, you got Pythagoras, and then now you're studying law of sine. Very simple. If you notice, in Sohcahtoa, I mentioned 90 degree. In Pythagoras also, I mentioned 90 degree. But however, you notice in law of sine, there is no 90 degree there. So it's quite obvious. There are two sets of formula. This one you use for non-90 degree, non-right angle triangle, whereas the Pythagoras and Sohcahtoa you use for 90 degree. Okay, so that means if your triangle is an obtuse triangle, that means more than 90 degree, you are required to use these two sets of formula. So I'm going to teach you guys how we actually use this formula. Law of sine is quite easy. Remember, for this angle, this is my partner. And for this angle, this is my partner. How we work with this formula is quite easy. I label this angle as angle theta1. This is as theta2. As I mentioned just now verbally, theta1, I'll write as sine theta1 divided by the neighbor, which is A, equals to sine theta2 divided by the neighbor, which is C. So the concept is in law of sine is that we are looking at the level of neighboring system. Okay, so for one neighbor will be the other side, the another neighbor will be the other side. Okay, that's how we do sine. So now we look into the law of cosine. Like I mentioned just now to you guys, if you notice in this triangle also there's no 90 degree involvement. That means law of cosine you only use for a non-right angle triangle. That means a triangle that doesn't have a 90 degree. In a simple word, it's also known as the obtuse triangle. So that's why I said just now earlier, you have two sets of formula. One we use for 90 degree, which is the Sohcahtoa and Pythagoras. And when it's a not right angle triangle, we use for the sine rule and cosine rule. How cosine rule work is very easy. I'll just show you guys the formula. My concept is like this. It's a mixture of a Pythagoras with a several component of cosine rule. If you still can recall, our Pythagoras mentioned that a square plus b square equals to c square. And you can see the resemblance over here. You can see the resemblance at here. Okay, so the front part of our formula is comprising of the Pythagoras, subtracting with 2ab cos c. That's all. Okay, so how a cosine rule work? Cosine rule work in a way that if let's say I would like to find this angle here, take note. Okay, wait. Also same, we still use the concept of neighboring system. If I want to find this angle here, I label angle C because it's associated with the edge of C. So for this angle C, my neighbor is C. Therefore, their location should be here and cos C. Remember that because we have experience that student actually the C they accidentally substitute as A and B. Please don't ever do this mistake. If I want to find angle C, I must make sure my angle C is located after the cos, and the length C is actually located at the edge. They actually at the end corner, like how our diagram is, both are actually corresponding to the opposite. Likewise, also here, the length and the angle will be sitting at the end of the formula. That's how you can actually take away to remember the formula. And I think we have one more we need to cover, the area for triangle. For area for triangle for right angle is quite easy. You guys know it's just 1/2 height times base. But remember, this formula is only applicable for 90 degree. Whereas for a triangle which is not 90 degree, we will use a slightly different approach. Wait now, guys. We'll use a different approach, which is this formula: 1/2 AB sine C. Also same, please take note, your angle must be in between two lengths. Okay, maybe I'll increase my width a bit. Remember, cosine rule or sine rule or whatever rule that you are using, when you use this formula, you must ensure that your angle is in between. You see, I'm going to label here, your angle must be in between A and B. You cannot simply take the theta somewhere and the length is not in between. This is a mandatory rule. Okay, your angle must be in between, okay, in between two lengths. Please take note of that. Okay, so when you want to use this formula or cosine rule formula, also same thing. Your angle must be in between the two lengths. That is pretty much about this formulas. Later we do partial, understand better. And we have another one that we need to cover. Wait, guys. Wait, here. Okay, next one I want to cover is bearing versus direction. I have nothing much to talk about bearing. I'll just keep it as simple as I can. The whole idea about bearing you need to know is bearing is always start from north. It's compulsory to start from north and it will go clockwise. I have in experience in the past, a student asked me why clockwise, why not counterclockwise? Actually, you go counterclockwise, clockwise, the same thing. But then the way we read a value from person A and person B will be different. So we cannot use that as a base law to measure a direction. Because, like for example, if Malaysia is using kilometer and in America they are using miles per hour for their car, can you imagine if you want to import the car, how hard it's going to be for us to standardize? That is why for bearing, because bearing is a universal thing, it's using by airplane, by ships and a lot of stuff, so they keep it universal. But you know, for the car part, I can't help lah. Okay, they insist they want to do left-hand driving or right-hand driving or whatever. Okay, so I guess pretty much like that. Now we will cover some questions relevant to trigonometry before we pursue with some partial questions. Okay, I won't do all. I'll select some only because it's just a repetitive format, which I don't think we need to do it again and again. Okay, yeah. Okay, so we'll start now. All right, so now we're gonna see some questions, how we can do these questions. Okay, so if you see what they mentioned to you guys, I'm not sure whether it's okay. My voice is being recorded. Okay, good. I was afraid it's not recorded. So they say find the length of the unknown sides and the value of sine x, cos x, and tangent x. So they want you to find the value of the sine x lah. Okay, so let's focus. I mean, not say focus. Let's analyze our question. Right now, they want you to find the angle of x. So what we can do is actually, like I said, imagine this is your eyeball, right? For your eyeball, this very thing is your opposite. That means I have my opposite, and like I said, the neighbor is connected by a 90 degree, and this must be your adjacent. So you're going to recall back the formula: car, saw, and toa. So the only formula that fit among all these three is tangent. Therefore, the wise decision will be for us to use tangent. Okay, so I'm going to use tangent for question 1A. Tangent x, because we don't know what is tangent x, right? Wait, my writing is too big. I think I need to reduce the size. All right, so for tangent x, the formula is going to be 5/6. So like I said just now in the explanation, and I shift tangent, become tangent inverse. Tangent inverse 5/6. Of course, this thing you can't calculate manually. You need to use calculator for that, and you'll get 39.8. Okay, so your answer is 39.8. Please don't round out to 40 because you need to leave in a 3 significant figure. That's number 1A. Now, for number 1B, if you notice, they already provided for you the angle. So for this very angle here, this is my opposite. So if this is my opposite, remember I told you the one that connected by the 90 degree must be your adjacent. So this is your hypotenuse. Okay, this is your hypotenuse. What I'm going to do right now, I'm just going to figure out which formula can fit perfectly within the criteria that I have. I want to find my opposite and I have my hypotenuse. So basically we are looking at the level of O and H. The only formula that involves O and H is saw. So the best will be using saw lah. Okay. So sine, sine 35 equals to x over 7. So if I want to find x, it will be shift 7 there. 7 sine 35. Okay, so I can just press in my calculator and I should get 7 sine 35. I'll get 4.01. I mean, it's three significant figures, so we can make it to 4.02 cm. Okay, so you can see this is how we use the Sohcahtoa. Actually, it's not really that hard, and I don't want to cover a lot because you can try. Okay, probably we will save the time to go and invest. I mean, go find some other questions lah. Okay, now let's look at question D. In question D is a bit problem solving question. I got D and E. I'll do D for you, and you can try yourself E. Of course, you can access the link to this slide. I'll upload in the YouTube description below. Okay. Okay, for question D, what we want to find in question D is, oh my God, I want to find question D. So in question D, they want you to find again, wait, instruction, there's no instruction here, I think. Wait, let me just cross check the instructions. I must have instruction, no instruction, how I'm going to find instruction lah. Disappointed. Okay, I assume they are asking you to find the value of A and B lah. Okay, I assume they're asking you to find the value of B because A and B is the one that is missing there. Like I said, for this angle, this is your eyeball. This is going to be your opposite. And there's a 90 degree there. They didn't draw for you. So this must be your adjacent. So this is your hypotenuse. So in our formula says, let's see what we have. We have our opposite and hypotenuse. Basically, we want to find our opposite and we have our hypotenuse. So opposite and hypotenuse, the best formula will be sine. Okay. The best will be sine now, obviously. Okay. So sine, wait guys, sine 60 equals to A over H, which is 5. The 5 I shift there, my A is going to be sine 60 times 5. So sine 60, if I'm not mistaken, is half. It's half or the set 3 over 2. Yeah, it's set 3 over 2. It doesn't matter, whatever. Times 5, I'm going to get 4.33. So that's my value of A, 4.33. Whereas for B, I need to erase a little bit because I want to look at the value of B. I think the lead size is too small already. Okay, so for value of B, let's see what we have. For this very angle here, I have the opposite and this is my adjacent, okay, because it's connected by 90 degree. So which formula fit between these two will be, I would rather say, okay, we have a problem here because why? We are lacking of, oh no, we got A value already. A is 4.33. So we can just use tangent lah. Okay, so I'm going to use tangent. Wait a while guys, I'm just going to use tangent. So for tangent 50 equals to opposite, which is A we already found earlier, 4.33 divided by my B. So to find the B will be, you do a bit of shifting there. So 4.33 divided by tangent 50, and you can press in your calculator, you should get the answer. 4.33 divided by tangent 50. Okay, so you get 3.63 lah. Okay, you get 3.63 cm. Finish. So that's how pretty much you do this question. I don't want to do E because you can try yourself. It's much more better. Okay, you can try question E by yourself, guys. Okay, oh my God, wait, my mouse is hanging. It's common lah. Wait, probably if I clear the whole screen, I redo back, should be okay, but I guess we're almost there already. Now let's look into the next question. Okay, next question, they want you to find the perimeter of certain area. Okay, let's see. They want you to find perimeter and the area at the same time. I don't do question A and B. Question A and B is the most easiest. Probably I just look at question C. Okay, so for question 2C, we want to find the perimeter. I know this is 7, this is 7, but now I don't know what is my length at here. You all agree with me, right? Because perimeter means I must have everything. To find the perimeter, I need to have everything. So right now, I'm lacking this green color. How can I find the green color will be? Remember, I told you a whole circle circumference, okay? The entire circle circumference, let me just write the circumference is actually 2 pi r. If I want to find the length of an arc, okay, length of an arc, like I said, because we are looking at one portion, it'll be theta over 360 times 2 pi r. So likewise, I'm going to do here, I label this as C. To find C will be theta, which was 90 over 360, guys, over 360 times with 2 times with pi times with my radius, which is 7. Okay, so you can press your calculator, you should get your answer 90 over 360 times 2 times pi times r, which is 7, and I'll get 10.9, so it becomes 11.0 cm square. I mean not square, 11 cm. Okay, so now I got the C. Find the perimeter will be 7 plus 7 plus 11.0. 14 plus 11 is 25.0 cm. So I found the perimeter already. Now we want to find the area. For the area, if I mentioned to you before, area of an entire circle will be pi r square. Likewise, area for a sector will be, like I said, we take portion of it, so it's theta over 360 times pi times r square. Okay, so I'm going to do the area here, 90 over 360 times with pi times with radius square, which is 7 square. Okay, so you can press in calculator and you can double check a formula. 90 over 360 times pi times 7 square, and I'll get about 38.48, so it's 38.5. So 38.5 cm square. That's how we do this question. Okay, so yeah, the A and B, because it's a circle, so you can just plug and play the formula. It's not a big deal there. That is why I didn't want to explore a lot of things on that part there. Guys, it's hanging a bit. Okay, now we go for our next question. In our next question, they want you to find what again? They give you find the length of arc. Okay, I think this question is just you need to substitute and do only. I don't want to do this question. You can try. You need some help, you let me know. I'll definitely discuss with you guys. Okay, I think we should actually go through to pass here already. Let's see what this one. Find the radius of the following circle when the given area subtend. Okay, this one we can do lah. Okay, I'll do this question for you. Because why? They ask you to find the radius of the circle when the sector given by. Okay, so what this question is trying to tell you, they already give you this sector. They already give you the area of this sector, which is 13.1 cm square. And they given to you the angle 60 degree. They want to find the radius. So for this question, first you must know what is the formula to calculate the area of a sector. So I'm going to write the area of a sector will be 60 over 360 times pi times r square. Right now, we don't know what is our radius, but we know what is our area. Our area they provided to us, which is 13.1. So I just need to do a little bit of shifting here. So 13.1 is equals to 6. Yeah, no, it's not 6. It's 1 over 6 times pi times r square. So what I'll do, I'll shift the 6 there. And I'll write the final answer. I'll skip here a bit. 13.1 times 6 divided by pi equals to r square. Okay, you can press in calculator. 13.1 times 6 divided by pi, I have 25.0 something, and then you square root the answer, you're going to get exactly 5. So your radius is just 5 cm. Okay, so you have any question or what, don't just drop a comment or something, or make an appointment with me or Miss Marissa. We will help you. Pretty much like that lah. Okay, this question, probably we can do this question. This question is not really that hard, but it's just a bit challenging. Before I even start this question, I'll show you a trick. This is definitely 90 degree. Okay, that's definitely 90 degree. There's no doubt about that. Okay, so this thing is 90 degree over there. What we need to find, they want you to find angle of POM, this little angle up there. They want you to find. So what we can do, we can actually use cosine rule if you want, or you can use Sohcahtoa. For me, I think I use cosine rule. Okay, why I use cosine rule? Okay, you can see if this is 3.5, this is 3.5 because it's the radius. In our cosine rule, they already mentioned you can use cosine rule if you have all three lengths, provided the angle you want to find is subtended by that. So you can see I already got this 5.2. I got it 3.5. I got it 3.5, and I want to find the angle subtended between two lengths. So the best will be using cosine rule for this question. I'm going to write here 5.2 equals to 3.5 square plus 3.5 square minus 2, 3.5 cos, guys, cos angle POM. So I don't know what's the angle POM, and just write here POM. What we do, we shift everything one by one. I forgot C square, so I should have C square here. Therefore, 5.2 square minus 3.5 square minus 3.5 square and divided by, okay, this part student will get confused a bit. I'm going to show in a bracket. This whole thing is actually being multiplied with cos. Okay, right now I want to find my cos, so I bring that, become divide. Negative 2, 3.5, and then 3.5 equals to cos angle POM. You can press this whole thing in calculator. Okay, I'm going to press this whole thing in calculator to see what I get. 5.2 square minus 3.5 square minus 3.5 square divided by -2 times 3.5 times 3.5, and I should get about something over that beta, guys. I think I make a mistake already. 5.2 square minus 3.5 square minus 3.5 square and then close bracket divided by -2. Wait, -2 times 3.5 times 3.5 times, yeah, okay. So pretty much like that. Okay, there's some problem here. Let me just rectify the problem. 5.2 square, I bring the 3.5 and 3.5 that side. I'm not getting what I should get. 5.2 square, wait, 5.2 square minus 3.5 square minus 3.5 square. Okay. Oh, I know why already. Wait, guys. Because we want to find the angle in bit angle POM, right? So this is 3.5, this is 3.5. The length of chord PQ is 5.2. 5.2. Something is wrong in this question, because if you use cosine rule, when you subtract with these two, that means c square equals to a plus b square, you should get the answer. You should get a negative on top, but now we are not getting a negative. Minus 2ab cos c. Okay, that's interesting. Just give me a time. Let me just think. Okay, give me some time. Wait. Hey, why am I not sharing the screen one? Just give me some time. Okay, guys. So what was the problem here is actually we are getting the angle in negative. Actually, the angle should be negative. And after I try to inspect why and why, I kind of get the concept is that we cannot use cosine rule for this formula. Not to say cannot use cosine rule for this formula, because this will become a cyclic prism. If you can see a situation inside a prism, so a situation inside prism, we have a 3.5 and 3.5. So when we cannot cancel, eventually this angle must go off. But right now the angle is not going off. So just give me some time. Okay. Wait. Yeah, we still can do it. Okay, it's not really a big problem. We still can do it. So after you press shift, after you do all this division, you're going to get negative 0.104. Okay, so you want to find that angle, you need to shift the cos over, so it'll become inverse cos negative 0.104. Okay, and that should give you your answer of 95.95. So you get 96 degree. That's your angle accurately. Okay, so if you have any question, you can feel free to drop an email or something. I guess we'll go on with our next question. Let's see what else question do we have. Yeah, we are entering past year question. Okay, so past year question we do in the second session. Okay, I mean, not to say second session, we will do later. So I'll stop here for now and we'll continue later. Okay. All right, guys. We're gonna continue with our past year question as I promised. Okay, so we're doing a past year question, and let's see how can it be. Okay, so let's see the first question first. Okay, so in the first question, if you notice, let me zoom a little bit up so that you can have a good view of what you are expecting to see. Okay, so they say the diagram shows a solid made from a cuboid and hemisphere. The cuboid is measured 12 by 16 by 24, whereas the hemisphere has a radius of 5 cm. And they want you to find the volume of the solid. So meaning in this question, what they're trying to tell to you guys is that the hemisphere and the what we call that, the cuboid, has been combined. So they want to know what's the entire solid shape after we combine them. Okay. So to find the volume, first we need to understand several things. Okay, one of that we need to identify will be, one of that is the length, width, and thickness. Okay, so we have all three. So I'm going to label this as A. I'm going to label this as B. Wait, I label as B. Okay, wait, let me just adjust all my colors together, so it's much more easier for me to do with it. So I'm going to find for my volume of A first. So volume of A will be, basically it's just a multiple of length, width, and height. So 24 times 16 times with 12. Okay. So when you times with all of this, now guys, Okay, so you should get your answer about 4870 cm cube. So this is the volume for the cuboid. Now the volume for the hemisphere will be, I'm going to write the volume of B, since I label B. So of course there is no need for you to show, but one can. Therefore, remember the volume of a hemisphere, the formula to calculate volume of a sphere is 4 over 3 pi, radius is 5 cube. However, we are looking at the level of hemisphere. Therefore, I need to divide by 2. Okay, because the top formula is the formula to calculate a whole hemisphere. Divide by 2 to get the hemisphere. Sorry, this one the answer is not 480. I just calculated the total answer is 480. Okay, so when you do this separately, you're going to get a certain value. Let me just get the value up for you. 24 times 16 times 12, and I'm going to get here 4608. Okay, so here is 4608 cm cube, whereas this will be 4 over 3 times beta, 4 over 3 times pi times 5 cube. Okay, 5 cube divided by 2. I'm going to get 261.79. So we'll make it 262 cm cube. And the total will be 4608 plus 262. And yes, we got the answer that we're looking for. 4870 cm cube. That's how we do. Okay, so the first one is of course easy. Let's look at the next one. Now the next one is here, the volume of the similar solid where the radius of the hemisphere is 3 cm. Okay, this is the most, I mean, not to say most, the keyword here is similar solid. Whenever you see similar solid, you should remember in the class that your teachers has taught you guys before, it's about this formula here. I don't know whether you remember or not. You remember there's a thing we call cm cube over cm cube and cm over cm. These are the level that we are looking at. So I've taught you guys before, if this is cube, this is not cube. Whenever we do ratio, remember whenever we do ratio, our domain or dimension or whatever you can call it, that means left and right must be same. So right now we are looking at a cubic level and a power 1 level, which is not balanced. So we can't do that. I'm going to use the same similar method to do this. There are a few ways you can do this question actually. So what I would do is actually, since this is similar, wait guys, let me just think. Okay. Yeah, because this is similar, nothing much will change. Okay, they just want to find the solid volume of a similar solid. Oh, okay, it doesn't matter. They just want a volume of a similar solid where the radius of the hemisphere is 3 cm. So that means the same shape. We didn't change anything, but we only changed one thing, which is radius. So we can just use back the formula. It's not a big deal there. Okay. So here my formula is going to be 4 over, sorry, my bad. It should be 2 over 3 because it's a hemisphere, right? Or maybe I write it properly for you. So 4 over 3 pi. Our radius is 3 this time. Okay, because initially it was 5, now it's this, and then plus with the cube formula. Okay, but the cube formula is a bit trick. Because why? They are reduced by what we call that. They are reduced by wait guys. Yeah, actually I realized we don't have to do that way. Okay, we can do what ways because this is similar shape. I'm going to compare. For now this 4870, which is the larger one, cm cube, the radius was 5 cm. However, for the new one, we don't know, but they already said it's 3 cm. Okay, like I mentioned just now, you need to make sure they are in the same domain. Right now they are not in the same domain. So what I'm going to do, I'm just going to cube the side. Okay, you can of course add that thing there. So I add cube so that both sides will be the same. Once the same, all we got to do is just a cross multiplication. So I'm going to cross multiplication. I know enough space I'm going to do here. So it's going to be 4870 times with 3 cube divided by 5 cube should give me my x. So if you calculate properly, you should get 1051.92. So I guess we can just stop at 1051 cm cube. Okay, so it's a 2-mark question. It shouldn't take you longer than that now. Okay, so if you have any question, please feel free to ask Miss Marisa or Miss me or any of our SGIS Maths department teacher. Okay, you can just approach anyone. They are quite friendly to help you. Now they want you to find the total surface area. Okay, so we want to find total surface area. We have few surface area that we're looking at. Let's just analyze properly. For this front part, I got 2 because front and back, so I'm just going to write 2a. For this side, I got 2, which is 2b, front and back. And from the bottom, I have another one. But then the bottom one, I think it's okay. Okay, the bottom one, I think should be no problem now. We just proceed first, because why? Some students will tell me that, sir, but the bottom on top is some part taken by the hemisphere. It's okay, just chill. Okay, I'll find a way to do it. All right. So what we will do first, we just focus on the cuboid. Okay, so I'm going to write here cube. We just focus on the cube. So for the a part will be, I just read out for you guys. Okay, for to calculate the a will be basically 2 times 24 times 16. Wait, it's not very it's not presented greatly there. So 2 times 24 times 16. Okay, this is the part A. Add with our part B. So our part B will be 12 times 24. Oh my god, okay, guys, 12 times 24 times 2. Okay, add with the bottom. Okay, 16 times 12 times 2. Okay, so all this value is going to give us the, what we call that, my bad, it's going to give us a cube surface area. Okay, it's going to give us a cube surface area. However, right now I know you will be feeling that, sir, but this top part, you know, only there's few part, only the another part is covered by the hemisphere. So that's why you need to be sure that this thing here, I'm going to label C, you need to subtract, because right now we're finding the whole square. So I need to subtract, which is the circle. Okay, so I'm going to show you here minus pi 5 square. Okay, because we want only this surface area. Can you see? I do in the blue color. Yeah, we only want that part, but there's something disturbing us, which is in the middle. There's a circle. So you just find the whole square, and you subtract with the, what we call that, with the circle. But then this is a problem here, my bad. Let me just correct this whole thing properly, because the down one is a complete, but the up one is not complete. So we need to do down and up separately. 12 times 16 here, and then plus again 12 times 16, but we only minus only for this thing. Okay, because this one is illustrating the top part there, and then I need to add the what we call that, the hemisphere surface area lah. Okay, so a whole sphere area is actually 4 pi r square. Since this is a hemisphere, so we're going to put 4, I'll just do as usual. Okay, 4 pi 5 square divided by 2. All this you can just press your calculator. You should get 1810 cm square as the total surface area. Okay, so I repeat one more time. 2a and 2b is not a problem, but 2c was a problem. So you find the down one complete, which is here. And then for the top one, we find this shape first. Then we minus with the circle, is going to give us the remaining shape. That's all about the question. All right. Now let's look into the next question, which is the total surface area of a similar solid. The radius of the hemisphere is 6 cm. Okay, same concept we're going to use now. We're going to play the same concept. They say total surface area. So it's 1810, whereby that hemisphere was, wait, I write like this is not good. I'm going to write here 1810 cm square equals to 5 cm. And likewise, we don't know what the new one is going to be. So I'm going to put here x because I don't know, but it must be x cm square divided by the new one, which is 6 cm. So like I said, the dimension is not the same. So we're going to square it to find the proper dimension. A simple cross multiplication will help you to ease your problem up. I'm going to get here 1810 multiply 6 division by 5 should give me the x. But if you notice, I make a mistake here already. I forgot to put the square. So that might give us a misleading answer. So here will be 1810 times 6 square divided by 5 square equals to x. Therefore, my x is going to be, you can just press your calculator. I believe the answer should be correct based on my logic. Yep, the answer is correct. We get 2606, which is within the answer limit. Okay, 2606 cm square. All right, so that's how you do this 2-mark question. I don't need to crack your head a lot. Wait, guys, I'm going to move a little bit. You can see all the questions, the answer I already placed it down there. So you can just go and view the answer if you are doing at home. Okay, So that one done. Let's say, do we have another part or not? Okay, that's question number 2 really. All right. So I guess probably we need to discuss question number 2. Yeah, let's start to discuss now question number 2. Okay. And in question number 2. Okay, hi everyone. Now we will continue with our next question number 2. Let's read the question first. Okay, so they were saying that the triangle can be made into a hollow cylinder with a height of 40 cm and show that the radius of the cylinder is 1.902. Okay, so what they're trying to tell you that they already give you the radius and they want you to prove that that's the radius. So how can we actually do this radius? If you notice, they said the rectangle can be made into an hollow cylinder. Okay, so this rectangle, when I fold, somehow I fold from here and I fold it in a circular motion, it's going to give me a cylinder shape. So in that in mind, you know, for your cylinder, the base, the circumference is going to be 40. Can you imagine that? You like take a string and you roll this string to become a circle. So that's the concept here. Okay, this piece of rectangle, I'm going to roll it like a Swiss roll and it become a cylinder. So what I can do, I can utilize this to our benefit, whereby 2 pi r equals to what we call that 40 cm. Okay, 2 pi r equals to 40 cm. And right now what I want to prove is that I want to prove this thing is actually wait, I guess the rectangle be made into hollow cylinder of height 40 cm. Okay, my bad. Okay, it's not 40 actually. They are rolling in this way. Okay, they are rolling this direction. So it's going to be a very small pipe or something like that. Okay, initially I said roll in the 40 cm. That means if I roll in the 40 cm, it's going to give me a bit different there. But right now we are rolling in terms of the 12 cm. Okay, so that means my circumference is going to be 12 cm. I'm going to write here 2 pi radius, which we don't know at this point of time. We don't know, so we're going to put here r equals to 12. So when I shift everything there, it's going to be 12 divided by 2 pi. So that's definitely going to give me about 1.910 cm. As simple as that. Okay, now the next one, they ask you to find the volume. This is going to be very easy. Just substitute the formula: pi radius 1.90 square multiplied with the height, which is 40. Okay, so you just have to sub everything inside. You should get 458 now, guys. Okay, 458 cm cube. As simple as that. So you can see some questions are not really that hard. Some questions are quite straightforward and direct. You don't need to think a lot to do this kind of questions. So pretty much like that. And we can proceed with the next part of this question. So the next part, they say the rectangle can also be made into a hollow cylinder with a height of 12 cm. Calculate the difference of the volume of this cylinder and the cylinder in part 1. Okay, so what they're trying to tell here, they say it can be made with a cylinder with a height, or hollow cylinder with a height of 12 cm. So this is actually similar to the just now's incident, like I said, but rather we're going to roll in this direction. Remember just now the question I said we roll on the 40 like a Swiss roll, but instead they roll on the 12. So now they want to roll instead of 12 and they want to know what's the difference in the height. So what we can do actually in this question is that we just proceed with finding the what we call that. We proceed with finding the volume first, and then I think we can work from there. Or you can do whichever way you want now. Okay, because I think this question have more than one ways to do. One way that I saw is that, okay, if I was you, what I'll do, you see, the only thing that affect this question between you and me is that, let me just adjust him. Initially we did do up here, right? So when we did up here, we got the volume for the height of 40. Right now the height has been reduced to significantly 12, and you want to know what's the volume. So actually we can use that technique also, no problem if you want to use that. Okay, I was thinking about using that, but I yet to decide. Wait, pi r square. I guess we can actually use that lah. Okay, we can use that, but I'm quite skeptical because they didn't use the word similar. If they use the word similar, then yes, we can do that. Okay, right now they didn't use the word similar, so it's quite a risk for us to use that technique, and some more it's a 4-mark question. So I think we rather just play safe lah. Okay, we play safe by we calculate it manually. So now since they roll here, of course we need the radius first. I'm going to write your radius. That means my quest to find my radius will be 2 pi r. We don't know. Okay, I don't know the r. Then I know my r should be, because 40. Okay, to find my r is going to be 40 divided by 2 pi. So now I can find the volume. Okay, so the volume will be pi, and my radius is 40 over 2 pi r square, and my height is going to be 12. Okay, so this what we call that No, we can't cut the pi. I think just the best is just substitute, press in your calculator. Okay, that will be much more accurate if you ask me. And you're going to get 51527.9 cm cube. But then they want you to give your answer correct to the nearest 10 cm. So if I want to give the answer to the correct nearest 10 cm, but haven't yet, they want to know the difference, right? So earlier the difference was about 458. So we need to subtract 458, and I'm going to get here 1070 cm cube. Okay, because why they want the answer in the near correct to the nearest 10 cm. So yeah, I already give correct to the nearest 10 cm. Okay, so pretty much like that. Now for the next question, let's see. Okay, this one we can use the method that I told you. Because why? They already give you the keyword that is mathematically similar to the actual one. So since they mentioned about that, I think it's wise to do it lah. Okay, so what I'm going to do here, they say the volume of the model is 75 cubic centimeter. So 75 cm cube, and they say the volume of the actual car is actual car, something is very wrong here, because they say the volume of the model is 75 cube and the volume of the actual car is 4.8. okay, whatever lah. So I'm just going to write here, and they say the scale is model to actual. Model is 1, actual we don't know how much. Okay, so I'm going to put here 1 to n. As usual, our ratio is not in the correct domain, so I'm going to put a cube there to ease the calculation a little bit. Then we can just do our cross multiplication. So n cube is equals to 4.8. We cross multiply 4.8 over 75, and then you're gonna do what over here is you're gonna cube root it. But I saw one problem. I know before you guys tell the problem, I will address to you the problem. Okay, I'm gonna cube root this, because why? This cube I shift over. So when I shift over the cube no more. Okay, so there's a cube down there, and what we can notice is that, guys, it will come in a while. Okay, so what we can notice, okay, so yeah, what we can notice, the unit is not the same. This is cubic meters, this is cubic centimeter. So we need to convert the unit. I will tell you what, is 4.8 we better convert to centimeter, much more better. Okay, oh yeah, no wonder it doesn't make sense just now. Wait, let me rewrite this nicely. Okay, so n is going to be, okay, cube root, you can't see the tree there. Okay, cube, oh my god, cube root. Okay, cube root a 4.8 times 100 cube divided by 75. Okay, you know why 100 cube, right? Because I'm converting meter to centimeter cube, and you should get your answer perfectly 40. That's all. Okay, so if anything you want to ask, like I said, just drop in an email and we'll be very glad to help you. Right, let's go to the next question. Okay, question 3. Okay, let's see question 3 what we have. I don't think I'll finish all because the rest is just relevant to the previous one. So of course you can try out, and if you've got any doubt you can clear with us lah. Okay, so in question 3 they want you to find the shortest distance between we want to find the shortest distance from C to AB. Guys, C to AB. I will shift a little bit here. Okay, I need to draw, right, the C to AB. So let me just draw it. Must draw. If you don't draw, you won't know what is going on. Okay, let me just adjust a little bit here. Okay, good one. Okay, so it's in the center. So I'm going to draw. So remember, shortest distance means is the perpendicular height that we're looking for. So the question, I want to find the shortest distance from B to AC. So B to AC, B to AC, my bad. That's not what we're looking for. They say B to AC. B to AC means the other way around. It should be like this. I'm just drawing estimated lah. It won't be so accurate, but I think it's like this. Yeah, this one make a lot of sense to me lah. Okay, yeah, so something like that. That's how the 90 degrees is going to be. So there will be a 90 degree at this point here, and we want to find that length. So what we can do actually, if you ask me what we can do actually, a bit challenging this question. Okay, assuming it's not gonna do us good. Probably we find AC first lah. Okay, if I don't find AC, I don't think there's any other way that I can do. So I'm going to find AC first. How can I find AC? I'm going to use sine rule. Okay, I mean cosine rule. So AC square equals to 11 square plus 12 square minus 2, 11 and 12 and then cos 60. Okay, so you press this in calculator, you should get cert 133. I'm going to leave in cert form for some reason because I need to carry this answer for the next step. Okay, so for the next part, what I will do is I'm going to find this little angle here. Okay, if I find this angle, it's going to solve all my problem. Okay, so I'm going to find that angle. How can I find that angle? If you look at my blue color cursor, this and for this green color angle, this is my opposite. And for this new length that we found, okay, we found the cert 133. This is going to be my opposite. So we're going to use a sine rule to solve this question. I'm going to speed up a little bit from here. So sine of angle ACB, which we yet to know, divided by 12 should equals to sine of 60 divided by cert 133. So with a simple cross multiplication, that can solve a lot of our problem. Okay, so sine angle ACB is going to be 12 sine 60 divided by cert 133. Okay, so you press your calculator, you'll get that angle easily 64.3. Now I got that angle, okay, and I got this 11 cm and I got a 90 degree there. I can just use sine rule. Okay, so I'm going to use sine 64.3 equals to for my sine, I need opposite over hypotenuse. So my opposite I don't know yet. So I'm going to put as the perpendicular. Then my opposite is the perpendicular length. So since I don't know, I'm just going to put that as height divided by my hypotenuse. I think height is quite misleading, okay, because h can be hypotenuse. I'll just put here SD. SD stands for the shortest distance. So my shortest distance is going to be 11 times with sine beta, guys, sine 64.3, and that should give me 9.91 cm. Right? So that's how you do this 7-mark question. Okay, you can of course watch slowly and understand. Now, these are not the only way you can do. Try some other way. They have more than one way to solve this kind of questions. All right. Okay, now for the next part, what we have is they want you to show that h is 7. Okay, so they want you to show h is 7. How can we do? Let's see what are the information. Oh, they already give you the volume. They already give you the volume. So to find the volume of a pyramid, the formula is basically, let me just write down here, B equals to 1/3 base times base area times height. So right now our volume is 112 equals to 1/3. Our base is 8 times 6, then times our height, which we don't know yet. Okay, so you do a little bit of shifting, you're going to get 7 cm, as easy as that. All right, and probably I'll just show you guys lah. Okay, probably I'll just show you guys how to do it. So we shift the 3 first. So 3 times 112, and then this whole thing you shift there. So it'll become 8 times 6 equals to my height, which also known as 7 cm. All right, now they want you to find the length of VR. Where is our length of VR? Okay, our length of VR is located somewhere here. So they want to know that length. Okay, but then we already got our height here. You can see I already got my height, and I can find actually I can find VR quite easy though. It's not really that hard. Okay, let's see what we have. Do we have any information? Do we have information? Okay, eventually we need to find this lah. Okay, eventually we need to find this thing here, this P, because if we don't have that, we cannot find VR. So how I can find that? I know this is a 90 degree here. You can see because you look from on top, it appears to be not. So I'm going to write here. I'm finding P. I'm finding PR. The PR is basically 8 square plus 6 square. And you're going to square root that thing, and I should get 10 cm, and yeah, 10 cm after you press. So half of it, MR should be 5 cm. So we already got our 5 cm, we got our height 7 cm, and I can find my VR easily using Pythagoras one more time. Okay, so 7 square plus 5 square, and you square root it, and you will get about 8.60 cm. Okay, so pretty much like that lah. Okay, if you have any question, as usual, just drop in an email or something. I've been repeating this all over again and again. And next question we have is question K. They say is the midpoint of something. Calculate KVL. How many mark? 3 mark. 3 mark. Okay, so they want you to find where is my K? K is the midpoint of PS and L. K is the midpoint of PS and the midpoint of QR. Wait, what? K is the midpoint of PS and the midpoint of QR. Oh, okay. They are looking at this lah. Okay, the middle there. So they want to find the angle of KVL. So K should be somewhere between here. KVL. Wait, guys. I need to digest this question a little bit. Okay, I need to digest this question. We want to find KVL. K is the midpoint of PS and L is the midpoint. Okay, I got it. Okay, so K is here and then L is here. So what they want you to find is this thing here. Okay, you can see I'm going to project all the way on top. That means a triangle inside a triangle. So they want you to find the angle sitting up there. Okay, so it's not really a big deal there. Okay, if you ask me, it's really not a big deal. You just need to know your what we call that, your units, and then you should be able to do. Okay, so from what I can see, they are sharing. We want to find that angle up there, right? I'm just going to extract. I hope you can see. I'm just going to use this triangle back. Can you see? So my height is initially 7, and then because this is 8, it should be 4. So I can find probably I can just use tangent lah. Yeah, I use tangent, should be okay already, and then times 2. Okay, because you see I'm actually calculating one part of that, then I just times 2 because I use this red color triangle over there. So for the probably I'll just write the angle. I should just write like this. Okay, so to find angle beta, to find tangent angle KVL is equals to, probably we find first and then later we do it. Okay, so tangent is opposite over adjacent. My opposite is 4, my adjacent is 7. Okay, then I haven't put 2 yet. I'm finding for 1 only. Okay, remember I put theta 1. So after you get that value, you just need to times 2 of whatever the thing is. No. Yeah, you need to shift the tangent over. Yeah, you need to shift the tangent over, and you just times to the answer. You should get 59.5. Okay, yeah, pretty much like that lah. Okay, that's how you do that question. And then maybe I can do question number 4, last one, and then I can call it a day for you guys. Okay, of course you need some homework, right? I can't do everything for you, and then you guys don't try anything. Okay, never mind, I'll just do. Okay, now this question is said the diagram shows 4 village ABC. Calculate the distance AC. Calculate the distance AC. So quite obvious, this one. They want you to find AC. I already got everything that I need. If I got this angle, that will solve my problem. I know this is a 90 degree there. So 360 minus 90 minus 50, I know inside here is 120. Okay. So for the matter of fact, I know this is 120. I can just use cos rule. It's quite obvious, right? So AC square equals to 10 square plus 12 square minus 2 10 12 cos 120. Okay, so my AC is going to be 364, which is eventually will give me 19.1 kilometer. Okay, so that's how you do it lah. Okay, now for the next question, you know how I do this, right? Because you see I have 2 length in between an angle. Okay, if I have 2 length in between an angle, of course I can use cosine rule to find the corresponding one. The trick is to use cosine rule. Remember, you must have angle in between them to find the neighboring system. Now using the sine rule, okay, this question quite specific. They already say you must use sine rule. Calculate angle ACB. Angle ACB. Okay, so this is the angle that we're looking at. So I'm going to label this as theta 2. They want you to find angle theta 2 using sine rule, which is not a big deal, to be honest. Okay, I can just use this. I can just use back sine 120 divided by 19.1 should equals to sine of unknown, the theta 2 divided by the 10 kilometer. So a simple cross multiplication will give me the answer. Sine theta 2 will give me the answer as 10 times sine 120 divided by 19.1, and you shift sine it, you're going to get 27.0. As simple as that. All right, so pretty much like that lah. We haven't really touched bearing part yet, so now we will look into bearing question. Okay, bearing question can be a bit challenging at times, but Of course, you know, right? Now they want you to calculate the bearing of D from C. Okay, so they want you to find the bearing of who? Bearing of D from C. So that means I need to draw my knot first. If I don't draw my knot, I won't be able to do this question. Okay, wait. Okay, this is my C here. I'm going to draw my knot. Okay, bear with me. Okay, so this is my knot here. And I want to find bearing of D from C. That means I need this angle all the way here. Okay, I need that angle there. Okay, wait. I erase first. Because they want C bearing of D from C, right? Yeah. This is the thing they're looking for. Let me read the question one more time. It's a calculate bearing of D from C. So I need this angle there. Okay, I need that angle. Earlier we already found this tiny angle up there, right? Correct me if I'm wrong. I think we found already. I have in my paper here. Angle ACB. Yep, it's 27. Okay, so this one here, we already got 27. Okay, and I don't know what is this angle here. So probably I think we need to rework to find that angle. You might be wondering, sir, we are missing another angle up here. This blue color. This blue color solved already, because you can see this is this rule. I use this rule. Okay, so as long two lines are parallel, this corresponding angle should be 180. So 180 minus 150, I get 30. So right now I need only this one angle left. Okay, wait. I changed my color. I only need this one angle. So how actually can I find that angle? I'll just use cosine rule. Okay, because I already got AC earlier. AC we already found earlier, which is 19.1. Okay, so this is 19.1. If I want to find this angle, I must make sure this is my C. Okay, so 18. Wait, guys. This question. Okay, so 18 square equals to 18 square plus 19.1 square plus 21 square minus 2 times 19.1 and 21. Wait, 20, oh shoot, 21 cos the angle that we're looking for, that purple color angle. Okay, so maybe I'll just label in purple color, this purple color angle. So eventually, after you do all your shifting, you're gonna get your angle as 53.1. Okay, correct me if I'm wrong. It should be 53.1. Now that I got that angle, it's quite easy to solve this question. Okay, so the bearing will be probably I'll just put in red color, so that bearing, so this one, red color. Okay, so the bearing will be 360 minus with 53.1 plus 27 plus the purple color. What's the purple color? No, the up that 30. So when you subtract all of this, you're going to get the bearing as 249.9 degree. As simple as that. All right. Okay. Next question. A straight path connects PB to the closest point P on AC. Okay. Let's see what the question is talking about. So they say a straight path BP. Okay. Don't know where is BP. BP is out of sight. Connects B to the closest point P on AC. Okay. The keyword is very simple. Okay. Very simple. Maybe some of you might not be able to read that question. They already say BP connect to the closest point. Actually, what they're trying to tell you here in simple English is the shortest distance. Okay, so they are referring to the shortest distance. So remember, shortest distance means must be perpendicular to the point that we are looking at. So right now we are looking at point B. So I'm going to try my very best to draw a 90 degree. It might not look like one, but just accept it. Okay, so you can see my projection. How I know it's 90 degree? Because it's the shortest distance. We have few ways you can do. I think the best way is just use sine rule, because you see I got a 90 degree angle here. Okay, so I can just use sine 27 equals to opposite over hypotenuse. So sine 27 equals to opposite which we want, the SD, shortest distance, divided by hypotenuse 12. So my SD is going to be 12 times sine 27. Okay, and I should have 5.8. It's not visible really. 5.45 kilometer. As simple as that. All right, guys. I think that's about it. Oh, let's see. Do we have? Oh, we have one more. Okay, fine lah. Let me finish it with you guys. Okay, since it's a clinic, let me do. Okay, the last one. What they say? Last one. They say the area within the calculate the area of the grassland. Okay, quite easy this question. They say ABC is the grassland. So they say this part, this red color part is only the grassland. you can use this formula. I'm going to write here area equals to 1/2 AB sine C. Sine C is what? What is our angle just now? What was our angle just now? Oh, actually, no need. What we can do, I noticed another one. You don't need to use 1/2 AB sine C. You can actually just use 1/2 height times base, because we got the perpendicular height anyway from just now's question. So 1/2, our height just now was, I think, 5.45, if I'm not mistaken. So yeah, actually you can use any formula. Like I say, maths is always like that. It's an open world. Don't rigid yourself to one formula. Okay, if you are okay with another one, then go ahead. As long as working is shown lah. So you get 5.45. What we call that? No, not 5.45. I think there's something wrong here. No. 5 times 19 itself already yeah, I know the answer. It's about 50, you will get 51.94. Okay, so you should get 51.94. Of course, significant figure. So like that, and kilometer square. Okay, that's all. So I think that's all for our maths clinic. Thank you so much for your time and your attention. And yeah, that's all. Bye, guys.